Okay, today we will be dividing fractions. And the first thing I want you to do is think about what we did in warm-up today with these questions. So let's discuss them. How many quarter hours are in 3 hours? So what we did was take 3 divided by a quarter, and you found that the answer was 12. How many thirds of a cup are in 2 cups? 2 divided by a third is equal to 6. How many half meters are in 5 meters? 5 divided by a half meter is equal to 10. And finally, how many eighths of a mile are in 4 miles? And you should have gotten 32. One thing that I want you to realize is that many of you probably didn't think of these as division with fraction problems, and instead came to your solution through reasoning and logic and multiplication. Also note that when dividing by a fraction, the answer will actually be larger than at least one of the starting points, and we'll talk about that a little bit later. But usually with division, we're used to things getting and broken up into smaller pieces. So this is what makes dividing fractions a little bit confusing. So when would you divide fractions? Well, here's an example. You're trying to figure out how many episodes of your favorite half-hour TV program you could watch in the 1.5 hours you have available after school before your mom gets home from work. When she gets home, she's going to make you do your homework. You probably came to the answer pretty quickly that 1.5 divided by half is equal to 3, because 3 halves fit in 1.5. You could watch 3 episodes of your show. When faced with division problems with whole numbers, like 18 divided by 6, we always think about equal groups. We have 18, which is our starting point. We call that the dividend. We're dividing it by the divisor, or how big the groups are. And we know that we have 3 equal groups. And this brings up that point that when you're dividing in whole numbers, usually you get something smaller. So that's why fractions are so abstract. Because when we divide fractions that are between 0 and 1, the quotient is going to be larger than at least one of our fractions. Look at this first one, a half divided by a half, right? It looks like this. 1/2 divided by a half. You're used to the concept of like a fancy form of 1. Well, here's a fancy form of 1. A fraction divided by a fraction is called a complex fraction, but it's really nothing to be afraid of because we can rewrite it in this form, and in a little bit you're going to have a strategy for how to deal with that. A half divided by 3/4 is equal to 2/3. And again, so abstract to just look at those fractions and be able to picture it. And it is very hard to draw as well. So I will try to show you at least one example of fraction circles divided out. So let's see how we can solve these kinds of problems. If you divide a whole number by a fraction, 3 divided by 1/4, we have 3 whole circles, and each circle has been divided into a 1/4 size pieces. How many of those 1/4s fit in 3 whole circles? So count them, right? So if I started with 3, how many groups that look like a 1/4 will I have? And the answer is 12. Okay, so that problem, 3 divided by a 1/4 is equal to 12. Can you see any other way you can manipulate these fractions and still get that answer of 12? How did you answer the first question in our warm-up today? How many quarter hours are in 3 hours? Did you use division? So how are we going to divide fractions? Well, we're going to use this example from our prior slide. there's going to be 6 steps, and I would like you to write these down. In step 1, you will convert all whole numbers and mixed numbers to improper fractions. Step 2, keep your first fraction, okay? A lot of times students will like to do something, move it, change it, whatever. The only thing you can do with the first fraction is put it into improper fraction form if it's a mixed number or a whole number. Step 3, we're going to now change the operation to multiplication because it seems like that's what you were using to solve these problems anyway. Step 4, this is a non-mathematical term, flip the second fraction. So what does it mean to flip a fraction? To flip a fraction means to find its reciprocal. Any number times its reciprocal is equal to 1. So if I want to find the reciprocal of 1/4, all I have to do is examine what it looks like to equal 1. How does that equal 1? Well, remember in multiplication of fractions, you multiply the numerators, right? And then you multiply the denominators. So this is equal to 4/4, which is that 1, of course. So 4/1 is the reciprocal of 1/4, because 1/4 times 4/1 is equal to 1. And the reason they say flip, can you think of a reason why they use this word flip? It kind of looks like it's been flipped upside down. Step 5, we're going to multiply, just like we learned in the previous lesson. Remember, you've already changed everything to either improper, right, if they were mixed, or whole. So once you keep, change, flip, then you're ready to multiply. So multiply your numerator, multiply your denominator. The final step, simplify if possible. So if you get a fraction over 1, you could just take it back to a whole number, which would be fine. Or if it's improper, like this is, if you divide, you can write the mixed number. So let's try a couple of these. The first example, 5/6 divided by 10/21. Remember, we're going to use multiplication, but in order to do so, we first look to see if there's anything that needs to be converted. Since they're both in fraction form, we don't have to convert. Then we will keep the first fraction, change to multiplication, and take the reciprocal of the second. So notice how they've changed. Now 21 is over 10. That's the reciprocal of 10/21. You can cross cancel at this step because now you're ready to multiply. Cancel out common factors, multiply, and then simplify. So 1 3/4. How about B? 9/14 divided by a -2/7. Remember, the integer rules for multiplication and division are the same. If they are like signs, your answer will always be positive. If they are unlike signs, your answer will always be negative. So looking at B, I know that it will be negative. So I'm going to keep the first one, change to multiplication, and then find the reciprocal of the second. So 9/14 times 7/2. Where that negative sign is won't matter as long as you remember to evaluate it. You can cross cancel to make the multiplication easier, and then your final step is to change it back to a mixed number to simplify. So a -2 1/4. In this example, we're dividing by a whole number. Remember that the first step is to convert mixed numbers and whole numbers into improper fractions. So remember, 3 is written as 3/1. That will help me to find the reciprocal. So 6 times 1/3, because the reciprocal of 3 is 1/3. Multiply and cancel if necessary. and then simplify. At this case, we don't have to. Let's try another. 5/8 divided by a negative 7/10. Nothing to convert. We'll keep the first fraction, change to multiplication, take the reciprocal of the second. So what does that look like? Let's slow it down. We want to rewrite our problem like this. And then we have, if you want to cancel before you multiply, which I like to do because it keeps the number smaller, we could divide out a factor of 2, and we get 4 here, and we get 5 here. So 5 times negative 5 is a negative 25. 4 times 7 is 28, and you could see that that's our final solution. How about this example? First step, we want to convert to improper fractions. Remember, when we do that, we multiply and then we add. So 14 times 10 is 140, plus 9 is 149 over 14. Again, ignore the negative sign and take 2 times 3, which is 6, plus 1, which is 7, and then bring in the negative sign. Now I have my division problem. Notice that I didn't flip it in this first step, and the reason I didn't do it is because your brain's already trying to do so much by converting that to improper. So first rewrite it with the improper fractions. Then work on keeping the first fraction, changing to multiplication, and finding the reciprocal of the second. The only thing I can cross cancel is the 2 and the 14. Therefore, I get 149 times 1, which is 149. That's divided by a negative 49. And then, to change it to a mixed number, I use division. So 149 divided by 49. And it's going to go in there 3 times, which is 147, with 2 remaining. So my simplified answer is, since this was a negative fraction, don't forget the negative, 3 and 2 over 49. State the reciprocal of the number. So here's where we're going to practice that, where we try finding the number or fraction that, when multiplied to what we see, will equal 1. So it's just like flipping it, right, upside down on its head, because the negative 24 over 7 times 7 over 24, doesn't matter which one's negative, equals 1, our reciprocal would be a negative 7 over 24. Doesn't matter which one you make negative. Since this is a whole number, whole numbers are fractions over 1, and then the reciprocal would be 1 over 264. We just saw in that last example, you have to first convert mixed numbers to improper before finding the reciprocal. So 20 times 2 is 40, plus 7 is equal to 47 over 20. So the reciprocal will be 20 over 47. Finally, a box of cereal contains 25.5 ounces of cereal. The recommended serving size is 2 1/10 ounce. How many servings are there in the box? Well, this is definitely a division, and I need to find out is how many times does 2 1/10 go into the 25.5. So my problem looks like this: 25.5 divided by 2 1/10. I need to change those numbers to improper fractions. 2 times 25 plus 1 is 51 over 2. 2 times 10 is 20 plus 1 is 21 over 10. And now I'm ready to keep the first fraction, change to multiplication, find the reciprocal of the second. The only thing to cross cancel is the 2 and the 10. When I multiply, 51 times 5 is 255 over 21. When I simplify, I get 12 1/7 of an ounce. This was our final example for lesson 2.9.